Okay, so one more set of examples here. We have a truck with a 50 kilogram table. We're trying to lift it up into the back of the truck, which is 1.4 meters off the ground. And the first question here wants us to calculate the weight of the table in newtons. So as a reminder, to calculate weight in newtons, it's F of G is equal to M times G. Once again, I'm sort of skipping some of the Dilsau steps, which you're not allowed to do, just to try and keep this video short and informative. Okay, so my mass is equal to 50 kilograms. And I'm going to multiply that times 9.8 meters per second, the acceleration due to gravity here on Earth. And when I multiply those two numbers together, I get 475 newtons as my answer for the weight of the table. So the next question wants us to calculate the amount of work done by Bill against gravity, which means that we want to know how much work it takes to lift the table up against the force of gravity, 1.4 meters. And so that means that we're calculating work using force times distance. And the force that we would be using in this case is the weight of the object in newtons, because that's the force that's working directly against us, times the distance that we're lifting it up, which is 1.4 meters. So when we do the math and we multiply those together, we get 665 joules is the amount of work done. So for continuation with this problem, we now have Bob, who's not as strong and wants to use this frictionless ramp. Frictionless is a key word there. And it gives us the input distance and it gives us the output distance. And we already calculated the output force on the previous question, the FO. So now it's asking us to calculate ideal mechanical advantage. So again, skipping some of the Dilsau steps, I'm just going to quickly show you how you could solve for the ideal mechanical advantage. DI is 4.2 meters. DO is 1.4 meters. My meters cross cancels. I end up with a final answer of 3. No units, right? IMA, mechanical advantage, is a unitless value. All right, and lastly, they want to know what the force is. That's Fi. What is our Fi for pushing the object up the ramp? So a reminder that IMA is equal to MA, right? So I already know my IMA is 3 and MA is FO over Fi. And if you watched the previous video, you saw how I switched this all around so that I could get Fi is equal to FO over 3. So now I can take the value that I calculated in the previous question for the output force. If I can find it on my paper, there it is, 475. So I end up with Fi is equal to 475 newtons over 3. And when I do the division, 475 divided by 3 is going to give me 158.33 joules. Is my final answer. So hopefully that'll help get you moving in the right direction. If you have questions, again, feel free to let me know.